Good afternoon, everybody, and thank you very much for inviting me today. It's a pleasure to be here. So my name is Julien, and I'm a tech evangelist with AWS. I've been working with them for about 2.5 years, and at the moment I'm the AI evangelist for EMEA. Right, and it's good to be in Paris, even though I get to do this in English again. So maybe one day I get to do it in French in Paris. Right? Okay. So why am I even standing in front of you today? Why do I even think I've got a good story to tell you? Well, you may have heard of this website, Amazon.com. I was started in 1995, and very early on, this is an actual screenshot from the website at the time. Very early on, Jeff Bezos, the founder of Amazon, understood that you had to personalize and customize the e-commerce experience. That the point of having a website was really to show to customers products that we thought they would like. Okay, and so very early on, you had personalization on that website, right? And that's probably a Netscape screenshot, if you remember that, 1995. Some of you were born, yeah? All right, I was. And over time, we kept working on this. And there's a really cool research paper that came out last year if you're into recommendation. I suppose you're interested in machine learning in general. That goes over the 2 decades of recommendation at Amazon.com. And so it's a very nice history of the evolution of recommendation, which is, of course, one of the main use cases for machine learning at Amazon. And the interesting thing is, you know, it really goes back to 1998, when the first patent was filed for recommendation by Amazon, at a time when other large companies that exist today didn't even exist, right? So we were already doing it. And it's not just on the website. Literally every single part of Amazon now is being run by machine learning. Probably you've seen those robots before. We have tens of thousands of robots in the fulfillment centers, and they pick up the shelves and they carry them to the people who actually prepare your orders, right? So, and they're not remote controlled, in case you're wondering. Somebody asked me that once. No, they're not. The Amazon Echo is obviously based on AI as well, and deep learning. This thing does natural language processing, text to speech, speech to text, etc., etc. So the device itself is just a device, but it's connected to the cloud. It's connected to AWS services that give it the capability to interact with us humans using natural language. You may have seen this one as well. It made the news recently. It's a store, actually, in Seattle. It's called Amazon Go. And what's so special about it? Well, you can just go in. You use your QR code in your mobile app to get in. So you go in and you pick stuff from the shelves, put the products in a bag, and then you just walk out. And there's no cashier. There are no lines, obviously. So unfortunately, you still have to pay, right? You can try running away, but there's a security guy at the front. And within minutes, you get in your mobile app your bill, right? And it's now open to the general public. So if you're visiting Seattle, please drop by and try it for yourself. And the way this is working, as you will see if you go there, is hundreds of cameras on the ceiling that do image recognition and image processing to see what people are picking and what they're doing with the products. So pretty cool use case. And this one is actually not a joke. When it was announced, people thought it was an April's Fool. Well, no, it's real. It's still under test, but it's coming your way, literally. It's a drone delivery service. And as you can imagine, this is heavily based on machine learning as well. So these are examples of Amazon using AI for 20 years internally, right, for their own purposes. And also, obviously, on the website, so for the customer's purposes. But I work for AWS, and the role of AWS is to build services that all of you can use, right? So we want to make sure every single developer out there, every data scientist can use the same AI tools as Amazon, the same AI tools as Netflix. Even if you're a startup, even if you're a small company, even if you're a student, you can go and open an account on AWS and use those same services. And some of those come directly from being used at Amazon, and we turn them into AWS services, and some are new. So really quickly, today we have 3 layers of services. So what we call the application services, and they're just super high level. You don't need to know anything about deep learning to use those. You just call an API and get the job done. So if you want to do image recognition, if you want to do text-to-speech, speech-to-text, NLP, so there is a translation service as well. You just call an API and you get your result. Okay? So these are really, really simple to use, and most of them are real-time. We have a lower layer of services, and I'll focus on that one today. For people who need to train on their own data sets, who need to build their own models, who need to tweak every single hyperparameter, which obviously you can't do and you don't want to do at this level. And we introduced at our tech conference in December called reInvent, we introduced a service called Amazon SageMaker, and this is the one I'm going to focus on today, because I believe this is the one that might be interesting to you. Okay, and at the lowest level, of course, you could still fire up EC2 instances, and we provide an AMI, an Amazon Machine Image, which here, if you're not familiar with AWS, is the file from which we build servers, right? And so this AMI is pre-installed with all the deep learning libraries, with the NVIDIA drivers if you want to do GPU training, the Anaconda distribution, etc., etc. So you just literally fire up your instance, wait for a few minutes, and you can get to work. Okay. And as it turns out, nothing on this, nothing in there would be interesting if people didn't actually use it. And we believe more AI is running on AWS than anywhere else. These are just a few references. So really big ones like Netflix and Zillow, and some startups like Duolingo that you probably know, and Expedia. The list goes on, and actually does go on. It didn't fit on one slide, so that's why I had to actually do 2 slides, maybe now 3 pretty soon. So we have a lot, right? So more references than anybody. So probably it goes to show that what we build for the customers is what they wanted. And so last year, customers asked us to focus on making the machine learning process simpler. So you guys know this, you're all experts. I'm not going to go and explain those steps, but framing the problem, collecting data, cleaning it, integrating it in your platform, starting to experiment with it, building features, training, evaluating the results, probably going back to the whiteboard a few times, right? Never works initially. And then once you're happy with the model, deploying it in production for inference, to serve predictions to apps. And of course, you need to do monitoring and debugging, and periodically you need to retrain because you have new data, and you want to have fresh models. Okay, so this is what the machine learning process looks like. And well, when you're a data scientist and you just graduate, you think you're going to be doing this, right? You think you're going to spend your life doing this and building cool visualization, and well, that's not the reality, right? You actually spend most of your time doing this, right? Then you have to rush and actually get something working. And in the meantime, probably you have to manage some servers because you want to train, right? And you guys have very big data sets, so you need GPUs and probably clusters of GPU instances. And then that's only half of the fun, because once you have the model, then you need to manage infrastructure to actually deploy this and serve your predictions, potentially 24/7. So you need high availability, you need scalability, you need security as well, etc. And those are more DevOps topics than data science topics. Okay, so even less time to spend on the black magic here, and more time on other things. And that's the specific problem that customers asked us to solve for them. They wanted us to build something that would actually simplify deployment, simplify training, and just let them focus on understanding the data, cleaning the data, preparing the data, and training, and just focusing on getting the best results possible out of the data. And so to do this, we built this service called Amazon SageMaker. I'm going to do a quick demo afterwards. And initially, when you start working with SageMaker, the first thing you do is you create a notebook instance. Okay, because the world is using Jupyter these days. And that's probably a good thing, and so we make it super easy to start a notebook instance. So just literally one click or one API call, wait for a few minutes, and you got a pre-installed EC2 instance with Jupyter and everything, and you actually open it and get directly into the Jupyter notebook. So no setup, no messing with Python packages, etc. It's all ready for you. Then actually, some customers said, we don't want to write machine learning code, right? Because maybe Amazon can do it better than we do. Maybe we don't have the skills. Maybe we don't have the budget. We just heard from two very big companies who have large teams, I suppose, but they're bigger companies, and not everybody can afford to build data science teams and have infrastructure, etc. So customers told us, can you please write built-in algos that we could use out of the box? So that's one thing with it. So let me take a few examples. I'm not going to take you all through all of those. Here's an example. This is factorization machines. It's a popular algo. You can do lots of things with it, like recommendation, for example. And so we provide in SageMaker our own implementation of factorization machines. And as it turns out, it exhibits perfect scaling. So if you train on 10 machines, or if you train on 20 machines, or if you train on 50 machines, you have perfect linearity, right? So you double the number of machines and you divide the training time by 2, okay? And if we compare this, and this was trained, these are actual numbers from a 1 terabyte ad tech data set, which are known to be pretty difficult to predict, right? And if we compare this to other implementation, we see that, well, you know, we're pretty competitive when it comes to accuracy and when it comes to classification and computing time. So pretty good implementation, and it's just there for you to grab. Another one for natural language processing, it's called LDA, topic modeling. Again, this is off the shelf, and we trained this on 2 data sets. So here you have to compare orange, which is our implementation, to blue, which is another implementation on the same data set, right? So the y-axis is training time. It's pretty obvious. I think we did a good job here. And you have to compare green to purple. Again, our implementation versus another one on the same data set. Okay. And again, you use this without writing a single line of machine learning code. And well, I had to show sequence to sequence because it's in there, okay? And you know, I don't mean to compete. That's not the point. It's just, you know, that's a popular way to do machine translation as well. So this is again off the shelf, and it's actually based on an open source project we released. It's called Sockeye. It's implemented with the Apache MXNet deep learning library that we like. You can do multi-GPU training. Of course, you can do machine translation with it. And we trained it here on an English-German translation data set using 3 different instance types. So the orange one has 16 GPUs, the blue one has 8, and the green one has 2. And as you can see, well, we even with the smaller instance, we tend to converge to the state-of-the-art bleu score for this. Okay, so for some people, that's a simpler way to do machine translation. For you, of course, you want to tweak everything, so please keep tweaking with OpenNMT. That's perfectly fine. So these are just examples of built-in algos that people can grab, but they can also use, of course, if they're more advanced, they can bring their own training code. They can bring their own TensorFlow code, their own MXNet code, scikit-learn code, PyTorch. We also have integration with Spark. If you like Spark ML, you can integrate SageMaker in Spark ML pipelines. So we try to make it easy for our customers, whatever technology they use, to actually go and use SageMaker. Okay, so the main feature here is really, like I said, to get rid of infrastructure tasks, okay, which data scientists don't want to mess with usually. So using the SageMaker SDK, which I'll show you, it's super simple. In one API call, you can fire up as many instances as you need to get your training jobs done. And of course, once training is complete, the instance is shut down and you stop paying. Okay, and you just pay by the second. Okay, so you don't just pay whatever you have to pay, nothing more. We're working on a feature called hyperparameter optimization, which is another important one because typically when you do deep learning and machine learning, the most difficult thing is to figure out what the parameters should be, right? So there are a lot of recipes. I guess experience helps, but you know, it's still a lot of guessing, you know, guesstimates, right? Guessing games, learning rates, number of epochs, and whatnot. So using HPO, which will soon be available in SageMaker, we will, using a limited number of trainings, we'll be able to actually predict the optimal parameters for your training job. So taking away the guessing game and letting you reach better accuracy. And finally, once you have a working model, then you quickly want to deploy it into production, right? You want to see in real life, with real life traffic, how your model performs. And typically this is pretty complicated. In my experience, this is where most of the machine learning problems fail. Because in the data science environment, with the data science data test and the data set and all the tools, etc., you know, you've got your A/B test results and they're good because people know what they're doing, I guess. And then you put this in real life on real life servers with real life traffic, and you know, maybe the A/B test doesn't look so good anymore. Maybe the code doesn't scale. Maybe, and it's not maybe, it's usually. So here, again, by using the SageMaker SDK, you will be able to deploy the exact same model that you train in just one API call to production, to be and it will be able to you will be able to invoke it using an HTTP API. So before I show you a quick demo, of course you need infrastructure to do this. Okay, so we introduced a few months ago, in October, so yeah, it's 6 months ago, almost, a new instance type called the P3. And this family supports the latest NVIDIA GPUs, the V100. Not to be confused with the P100 that was referenced earlier. So the V100 is even one step further. And so you can, on demand, you can fire up instances with 1, 2, or 8 GPUs. And these are the most powerful ever, right? Until the next ones, but for now they're the most powerful ever. And you get crazy speed up compared to the previous generation. We also introduced a new family of CPU-based instances, Intel, of course, Intel-based. And we call them C5. C means compute, and 5 is the 5th generation for us. So these use the Skylake architecture. So as usual with Intel, it's more of everything, more cores, more memory, more bandwidth, etc., etc. But specifically what we like about that C5 family is that it supports a new instruction set. It's called AVX512, and it's a vectorized instruction set, which does a big difference when you do machine learning and deep learning, because you're going to be able to do basically linear algebra in parallel on those instances. Okay, and there's a very good speed up with those. All right, so let's do a quick demo here. And I will put the mic down, but I think I'm loud enough for everybody to hear me. Okay, so this is the SageMaker console. So if you have an AWS account, you can just go and open SageMaker. It's available in four regions today, including the Ireland region. So you can create your notebook instance. You can see all kinds of information about the jobs that you're running and the models that you're hosting, etc., etc. But let's not focus on this too much. So here's the notebook instance that I just opened. So once you open it, this is where you get into the Jupyter notebooks. We provide a large number of examples, and you will also find them on GitHub. I put the link, the URL in the slides. So we have a large number of notebooks that show you how to use the built-in algos, how to use MXNet, how to use TensorFlow, Spark, etc. So plenty of examples to actually learn about SageMaker. So let's look at a first example here. So I decided not to do machine translation because I wanted it to be nice, right? Happens to me sometimes to play nice. So, but I still wanted to show you language stuff. So I'm going to show you quickly how to use an algo that we wrote, that Amazon wrote. It's called Blazing Text, and it computes word embeddings, okay, which is usually the prerequisite to many NLP tasks. Okay, so this is one of the built-in algos that we designed. So we need to download the data set. Okay, so we're downloading the text A data set. It's a very tiny subset of Wikipedia, which is what we want here. I need to copy my data to S3 because this is where SageMaker is going to grab it. And then I'm going to select my algorithm, okay? And as you can see, this says containers. So don't worry, if you don't know much about containers and Docker, that's okay. The only thing that you need to know here is that, like I said, SageMaker is deployed in 4 different regions, and so we have a separate container for each region. Okay, so here I'm going to grab, I'm running in the US, one of the US regions, so I'm going to grab the container storing the Blazing Text implementation in that region. Okay, that's all you need to know. Okay, so now we have a lot of information about Blazing Text. And the next thing I need to do here is to configure my training job. Okay, remember, I'm using existing code, so I don't need to write any algo code here. So I'll just go and grab 2 instances. I can do distributed training if I want. So I'm going to distribute that training on 2 instances of this type, C4 to XL. Okay, so that's how I select the infrastructure that I need. I'm going to pick the hyperparameters for the algo itself. Of course, these are algo specific. They're all in the documentation. You could use default values or tweak. Okay. So now I need to summarize all of this stuff before creating the job. So the algo that I selected, the hyperparameters that I just showed you, where my data lives. So it's in S3, in an S3 bucket. Okay, just literally parameters. And then I call this SageMaker API here. Hopefully you can see this, yeah. Okay, create training job, passing the parameters, and that's all it takes. Okay, so this thing is going to fire up 2 EC2 instance of the right type, pull the Docker container, inject the parameters that you defined, point that thing at your data set in S3, and then it's going to train. Okay, and you just wait for the training job to complete. You can get some details in the SageMaker console. Okay, and once it's over, okay, I can see my vectors here. And if I want to be fancy, I can even display my vectors using TSNE, right? Okay, and again, even if you're not a machine learning expert, you can do this, right? You can grab the data set, put it in S3, configure the algo, get the training job going, and that's it. And like I showed you, these algos scales without any limit. Okay, there is no limit to the data set size they can process. Okay, so here's an example of using a built-in algo. So now the last thing I want to show you is how would you use SageMaker with your existing machine learning or deep learning code. Okay, so here I decided to show you sentiment analysis using MXNet code. If you're not familiar with MXNet, I think you should, right? It's our preferred deep learning library. We tend to build our own services with this, and we contribute a lot to the development as well. And as you can see, it's part of the Apache project, so no one owns it. It's driven by Apache, right? So no one could decide tomorrow to close the project, like some companies do sometimes, unfortunately. And I hate that. Okay, so as you will see, it's even simpler here. So I'm going to download a data set. So here it's a movie review data set. Okay, so it's just one line, and we tag them, positive or negative. Okay, we have about 80,000 samples here. Okay, so I download it, copy it to S3. Okay, and this is my training script actually. So this is my MXNet code that I could be running locally on my machine, or I could be running locally anywhere. Okay, it's a vanilla MXNet training script. It would be exactly the same with TensorFlow, right? Okay, so I just need to take that thing, and the only thing that I need to do is this, which I tend to like very much because I'm lazy. Okay, I just create an MXNet object in the SageMaker SDK. The actual training code is a parameter to this. And here, because I'm not paying my AWS bills, I decide to use 4 instances. So I'm gonna distribute that training on 4 instances of this type. Some hyperparameters for my script, for my MXNet script, and that's it. Okay, I call fit to get the party going, and I see my training script in there. And who said AWS developers didn't have a sense of humor? So there's a different color for each instance, actually. So this begs the question: when do they run out of colors, right? So obviously they managed 4, but I have to go and try bigger numbers. Okay, so I see my training log here, and then of course I want to test my model in real life. So I'm going to deploy it using the SageMaker SDK again, and all it takes is 1 line again. So deploy the model to 1 instance of this type. And again, this fires up an EC2 instance, pulls the MXNet container, injects the training script, etc., and the model, and creates an HTTP endpoint that you can query. Okay, 1 line of code. And so you can query it using, of course, the SageMaker SDK. So it looks like a function call, but here we're really calling an API, and obviously you could be calling that API using the HTTP protocol from anywhere. Okay, so let's try it. Hopefully I'm still connected. Yes. All right, so I can see my binary classifier is working here. Let's try another one, just for fun. Yeah, I hate it. Okay, and this is classified as a negative sentiment, which is exactly what I think of this movie. Okay, so this is an example of bringing your own script. I don't want to overrun, so you have other ways to use SageMaker. You could be bringing your own container if you wanted. So let's say you guys want to use the cafe library, right? Or you want to use one of those libraries for which we don't have an environment yet, okay? Or you have your custom training and prediction code that you wrote in C++ over the last 10 years, okay? Well, all you would have to do is build a Docker container that would just have to comply with a very simple specification that we provide. It's mostly about file layout and names, so that SageMaker is able to invoke your training script with the right name and your prediction script with the right name. So that's very simple. Then you can push that container to a repository in AWS, and then you can use it in exactly the same way. Right. So as you can see, you can go end to end from notebook to training to deployment, but you can also pick whatever you like. So if you want to work locally on your machine in a Jupyter notebook, you can do that, right? You can call the SageMaker SDK from your own machine and create training and prediction clusters. Or you could be training a model on your own infrastructure and you just want to use AWS to deploy it, and you could just use that deployment part. Or you would want to use AWS for training at scale and then deploy on your infrastructure, and that works too. Okay, so you can go end to end, or you can just pick whatever you like and leave the rest. Okay. All right, so just a few resources before I go. And of course, I will send you the slides, and you can distribute them. So the top level website for machine learning at AWS, if you're looking for a description of services and customer use cases, etc., this is the place to go. We have an AI blog where we do release a lot of content. So if you're looking for code, real life examples, and etc., that's the place to go. Then the SageMaker page, the SageMaker SDK on GitHub, the SageMaker Spark SDK on GitHub too. Again, if you want to integrate Spark, if you want to integrate SageMaker into your Spark pipelines, you can do that. All those notebooks that I showed you and many more are also available on GitHub. Okay, so you can just go and grab them. If you're interested in looking at the different ways in which you can use SageMaker, so built-in algo, bring my own script, bring my own container, all those different ways, I recorded a YouTube video that shows you. I go through a number of notebooks in detail and I show you how this works, right? So it's more examples and more detailed examples than what I did today. And last but not least, I'm actively blogging on Medium on deep learning, MXNet, and a few more things. So if you're interested in this, if you want to follow along, well, there are some good articles to read there, I suppose. Well, I'm done. Thank you very much. Thanks again for inviting me. And if you have some questions, I'll be happy to answer them. Thank you.
Is there any question for? So obviously you saw the similarity with the NMT wizard that we presented this morning. So we don't want to compete with Amazon, but no, just the idea of the container, running the container, bring your own container is definitely some convergence point on the two service the service you have announced this morning. Is there any question on this brilliant presentation from Julien?
They want coffee. Right.
Oh, there is
oh
one.
yeah, we're okay. Oh. I can stay around for coffee and then I have to run. It's not the end of my week, unfortunately.
Hi, what's the average cost of your presentation, for example, or hourly? Or
Oh, you mean my salary? Or well, it's more than anybody could afford, unfortunately. No, it's so here. The only things that you're gonna pay for is the notebook instance that you use. Okay, so I'm gonna answer your question while I find the pricing page, because one thing I forgot, I never want to remember, is the pricing, because it changes all the time. So let me give you the best tip today. Is when you're looking for AWS prices, this is what I do, right? Oops. So here you're going to pay for the notebook instance, and it's even in French, so that's beautiful. Okay, so you will pay by the second for the notebook instance that you use. Okay, but keep in mind you don't have to use them. Okay, it's a convenient way that we provide to you. But if you want to work on your laptop in your own Jupyter and perform SDK calls to SageMaker, that's fine. Obviously, you need an AWS account to do that. But so you can totally ignore that cost if you don't want to, if it's not your preferred way of working with a notebook. Okay, so all the costs are going to be they're from region to region. We have some variation. So let's see if we have an example here. It says example. Okay, so here, for example, if you, maybe that's too tiny here. Can you see this? Oh. Yeah. So, for example, if you use the small notebook instance, okay, which is more than enough because you're not doing you're not doing any processing there really. You're just hosting the notebook and performing calls. Some customers want to do cleaning and experimentation, and maybe they want to have a GPU on the notebook instance, but in general, it's not needed. So you're going to pay, 4.6 cents per hour, right? And you can stop it when you don't need to use it, right? And you just stop paying. And then you pay for, again, let's look at Ireland maybe. You pay for, so this says hour. It says tarif horaire, but it's actually per second, okay? You pay per second. So depending on the instance type that you use for training, you're going to pay a certain price, right? So that's it. So if this example that I did, I could really have used only one instance, honestly, right? So for example, the C4 2XL, which I used, cost 63 cents per hour, and my training lasted maybe 10 minutes. So that probably costed me 6 cents. But again, I'm not paying my bills. Some evil people say that's the reason why I joined AWS. But they're evil, right? So it's going to be fractions of dollars, and of course, remember that this stops automatically when training is done, okay? Which, is usually not the case. I mean, I've worked on pretty large Hadoop clusters and things like that in the past, and you never shut them down, right? So you buy tons of servers, you put them in a data center, and it's a lot of work to get them running. So the last thing you want to do is to shut them down. So they run all the time. They're on all the time, but they're not really training at 2 a.m. every night, are they? So it's actually it's a very competitive way of managing infrastructure. Okay, so it's the exact same. If you're familiar with the EC2, it's the exact same thing. The pricing is a bit different because it's not just the instance; it's also the service. But it's the same idea. You pay for what you use, and when you switch things off, you stop paying. Okay. Yeah. So the question is, do you get spot pricing on SageMaker? So give me 30 seconds to explain spot pricing. So these prices here, and in general, the EC2 prices that we mentioned are what we call on-demand prices. So you go to the console or you call an API, you create an instance, and you get it immediately. Okay, so it's on demand. We have another way for you to buy capacity, so it's called spot, and actually you're bidding on unused EC2 capacity. Okay, so we always have extra capacity, and you can go and buy it or rent it at a very deep discount, usually 70, 80%, sometimes more. Okay, so what's the catch? The catch is that if the price you're willing to pay is actually exceeded by the market price for that instance type, because it's a bid, right? Well, then you have 2 minutes before you lose the instance. Okay, which isn't really a problem unless you had the wrong ID to put your MySQL database on the Spot instance. But if you use Spot for web servers, stateless stuff, workers, etc., it works very well. Okay, so so the service was just launched in December, so we don't have Spot integration. I don't want to talk about the roadmap, but I suppose it's pretty high on the list, and a lot of people are asking for it. Okay, so and for that kind of job, it would make a lot of sense because those are really, your trainings are never gonna run for days and weeks, especially if you can distribute it. So if you could say, give me, even if I have a large data set, give me 100 Spot instances to distribute my training, and you get them at 90% discount, well, it's going to be the exact same cost as 10 instances at on-demand price, right? And the job should run 10 times faster. So even if so the chance of losing instances because the market price is going up is very low, actually. We have customers who use Hadoop even on this. They have 800, 900, 1,000 Hadoop nodes in Spot. And yeah, they lose a few, but that's okay. They don't lose data. The Hadoop can recover from that. So yeah, I'm definitely with you on that one. I'm hoping to see Spot in there.
Thank you very much, Julien.
Right. Thanks again.